Just a reminder, you guys, there's no after-school help today. All right, usually first Monday of the month, that's the case, and there's no after-school help today. New assignment sheet, new homework answers for this week are up on Classroom. That's all on you guys to see what the homework is and what's upcoming. Reminder, quiz on Friday. It's on your assignment sheet too. We got a quiz on Friday. Same setup as last week as far as the camera off to the side, your Chromebook in front of you, stylus, and making sure you do the test on formative on your Chromebook with a view from the side. All right, you guys did a nice job of that last week, and I appreciate that. So let's keep it going. All right, any questions there about what's upcoming this week? Quiz at the end of the week. And I know this is week 2 of remote learning, and cross your fingers, we'll be all back next week, back to our regular schedule. But expectations don't change because we're in the second week. All right, make sure we are on camera here full time. And also making sure we do not do the homework while I am teaching. I guess I have to remind you guys that every day, as I can see some of you guys go into your textbook right now, okay? If you didn't do it, sorry to hear that. Try to do it in the 2 hours I give you in between class and when you have to submit it by 1 o'clock. Okay? Not my problem. You guys had the weekend to do it in an honors level. So figure out a way to do it or just take the penalty. Your call. All right, here we go with the homework. Before I start taking questions, I want to make sure we're clear on what type of questions I'm looking for when you ask a homework question. When you ask a homework question, I'm assuming that you guys check the answer and still have no idea how I got to that answer. That's why you're asking, and that's what I expect. What I don't want is for you guys to ask a question because you didn't finish it, and you just want Mr. Carlino to do it so you can copy it down and get credit for it. That's not how we roll in honors. Okay, I'm finding more and more the same people are asking the last couple questions, and usually what that signals to me is you just didn't do it. That's why you're asking the last couple questions, the same people over and over again. Okay? So if you didn't do it, just, again, take the penalty or find some time to do it in the next 2 hours before 1 o'clock. If you have a genuine question, obviously I'll answer it, and we'll keep answering questions as long as it takes. But do not ask me a question because you did not do it. That's just pure laziness. Okay? Don't be scared to ask a question either now that I just said that, by the way. All right, because I know most of you are genuine and you have an actual question on how I got the answers. But if you're just lazy and you haven't done it, don't bother asking me, please. All right? So with that being said, which ones did we struggle on here? You didn't know how to start it from the beginning. You looked at the answer, not too sure how I got to the answer. Here we go. Where do we want to go?
27 and 49.
27 and 49?
Yeah.
Okay, let me go over 27. Okay, 27. How do I get to angle 4? All right, no problem. I'm going to... Hey, what's the deal here? Yeah, that's fine. You can go to your textbooks to look it up. That's fine. But once I start teaching here with the actual notes, then it's game over. All right, and I have it up on the screen here too. All right, big thing I tried to stress to you guys on Friday. Every single triangle, any figure with 3 sides has 180 degrees in it. Always has 180 degrees. I don't care if it's 2 triangles within a bigger one, 5 triangles within a bigger one. Every single 3-sided figure has 180 degrees on it. And I'm telling you this for this problem number 30 for 27 because you had to find angle 4. Take a look. Here is a triangle where I know 2 out of the 3 angles. I know 35, and they gave me the right angle symbol for angles 5 plus 6. So for angle 4, I could just say that's 180 minus the 35 minus the 90. Okay, to find angle 4 for that one. I got to find triangles that maybe I know 2 out of the 3 angles for. All right, so there is number 27. All right, here we go. 49, the challenge one. Pretty sure all year I've talked, do not set up an equation with multiple variables. Do not. All right, try to set up an equation where it's got a single variable all throughout. I say that. That is an exterior, actually, let me go to this one. 135 is an exterior angle. And we learned on Friday, an exterior angle is equal to the sum of the two remote interiors, meaning the two that are non-adjacent to it. In this case, it would be 5y plus 5 plus 4z plus 9. That's not what I want you to set up. You're never going to be successful trying to solve that with a y and a z in there. So that's out the window. Gone. All right. You do have another exterior angle, though. 9y minus 2. Can I do something with that? Yeah, you can. 9y minus 2, which is your exterior angle, should be equal to the sum of the two remotes. And now I'm going to turn it over to you guys now. What are the two, at least, how about this? Just give me one remote interior angle for 9y minus 2. That exterior angle, 9y minus 2, give me one remote interior for it. Here we go, 10, Atticus, here we go. 9y minus 2, give me one remote interior that is showing in my diagram.
5y plus 5.
5y plus 5 is one remote, plus now you'll see the other remote interior is not there. But it still exists. It's not 0. It's not a new variable. It's right next to 135. Let's use your geometry knowledge. If it's next to 135, I call that a linear pair, which means it's supplementary, which means this has to be 45. And there's my equation now. All right? Don't be brainwashed that whatever we do in class that day, that is the only thing you're allowed to use on homework that night. No. The whole year is fair game every night. The whole year is fair game. Okay? Just not what we went over that day. So everyone, all right, how I got this equation? Exterior equal to the sum of the two remotes. All right, you solve it for y. You do the algebra, which you show your work for, and you get 13. Now you got to find z. All right, I'm not going to tell you how to find z because there's multiple ways. There's not one way to find z. You could take 13, plug it in for y, and say these two add to 180. Solve for z. Another way, you could plug, again, 13 in for y up here. And now, remember the problem we had at the beginning? Now you could say 135 equals these two right here added up after you plug in 13 for y and solve for z. Multiple ways of going about this. There you go. There's number 49. Done. Next, others that you had concerns with.
I have a question about the same problem.
Yep.
So I know you said stay away from like two different variable like equations.
Yep.
But I set up two different ones so that I can do elimination. Is that wrong?
Nope, not at all. I don't say you have to stay away. I just prefer you stay away because not too many people would be able to handle two variables. But no, you don't have to stay away from that, no. Other questions? Other problems? If somebody just asked one, I have no idea which one it was.
Yeah, I have a question on the same one as well.
Yep.
So I know you can't do 135 equals 9y minus 2, but I don't know why. It just seems to make sense.
135 equals
9y minus 2.
Okay, how are they equal to each other?
Because I think they could add to 180. That's what
They could add to 180?
Yeah, because are they linear pairs or no?
The 135 and the 9y minus 2?
Yeah.
They can't be linear. Linear pairs means that they share a vertex and a common side. 135 here, you have this angle and this angle with the 9y minus 2. They do not share a vertex or a common side. Linear pairs have to be adjacent directly next to each other, sharing a vertex and a common side.
Okay.
All right. Other questions?
Can we do 22?
Okay, 22. Okay. Not getting concerned yet. What's the 100 degrees in this diagram? Anybody? What's the 100 degrees?
I want want to say the word is exterior angle.
It's an exterior angle. And what did we learn? That it's equal to the what? Sum of the two remote interiors, which means the two angles that are not next to 100. So it's going to be 2x plus 27 plus 2x minus 11. Exterior angle equals the sum of the two remote interiors. Even if you forgot that theorem, fine. 100, what's next to 100? 80, they're supplementary. Now you can take all three angles inside the triangle and add them up and set them equal to 180. Anything else? Last call? Okay, it is, what am I time here? Okay, 10:37. You got 2 minutes here to clean it up, submit it, and then I'm going to get going.
Mr. Carlino,
Yes.
every time I do 22, even if I do that like add the 80 thing, I get 21 instead of 31.
22?
Yeah, because it's you divide 84.
Are you finding x?
Yes.
Okay, but the problem didn't say find x.
Oh, okay.
Right? 22, find the measure of JKL. So you got to plug x back in. Okay, guys, I'm going to get going. If you didn't have a chance to submit it, you still have 2 hours and 20 minutes to submit it. So, all right, no problems. All right, let's get rolling. Moving on, a little bit different topic today. We're not going to talk about the actual angle measures inside or outside. We're going to actually start proving triangles congruent today. When are two triangles congruent? And yes, that means we are going back to statement, reasons, proofs. Before we do that, though, I need a concept for you guys to pick up, and that is what I'm calling corresponding parts. Corresponding parts. Okay, this is the last time I'm going to say it before I start calling guys out. Get off the textbook. All right, I don't know why we need to be on the textbook when we are taking notes. Thank you. All right, here we go. Corresponding parts. The last time you guys heard the word corresponding, was for parallel lines last unit. And it's almost the same type, except I don't have parallel lines anymore. Corresponding parts is I take a figure, put it right on top of the other figure I'm comparing it to, and tell me which angles are on top of each other and which sides. So in this problem right here, I got two quadrilaterals. And in the givens, I'm telling you that each of the quadrilaterals are congruent to each other. Both quadrilaterals are congruent. Real quick before I move on, this right here, because you're going to see this in your homework, this is called a congruent statement. When you tell me one figure is congruent to another, it's called a congruence statement. You guys will be writing your own by the end of today's class, your own congruent statement. All right? So you'll be writing your own congruent statement telling me one figure is congruent to another. All right. Now that I know the two figures are congruent, I'm going to try to take A, B, C, D, turn it, rotate it, flip it, whatever I need to do so it lands, boom, smack, directly on quadrilateral ZWXY. And what I want to know from you guys is, first, give me a pair of sides that would match up. I'm going to ask somebody right now, give me a pair of sides that would match up if I put ABCD directly on top of ZWXY. Okay, let's do this. Here we go. Owen, can you give me a pair of sides that would match up?
CB and XW.
Okay, CB would match up with XW. Good call. Now, because the quadrilaterals are congruent, so are any corresponding parts, which is what Owen just gave me. He gave me a pair of corresponding sides, so those two are congruent. Give me another pair of corresponding sides that we would say are congruent now. Let's keep going. 6. Here we go. Caroline, can you give me another pair of corresponding sides?
DA and YZ.
Yep. DA, YZ. Let's keep this fun going. Another pair of corresponding sides. Here we go.
So this is true if so even though it's true even if you have to rotate it a little, or if you need to like flip it.
Correct, and I will show you a way in a minute here after I'm done going through all the sides and angles where I don't even have to visualize it. I can just look at something else and tell. All right, but for now, yes, I'm asking you guys to flip it, turn it if you have to, what sides would match. Basically, take the shape of ABCD and make sure it fits on top of the shape of ZWXY. All right, Caroline, go ahead. You got another pair? Did I have? Nope, sorry, Emma, you're up. Sorry, Caroline, you're good. Emma, give me another pair.
DC and YX.
Yep. And the final pair of corresponding sides, which are now congruent. All right, here we go. Kyla, give me the last pair.
AB and WZ.
Yep. Or ZW, sorry. I wrote it backwards. Okay, everyone, all right. And I know they're why do I know they're congruent? Because the actual figures are congruent. So if the figures are congruent, so are the corresponding parts. All right, now let's go angles now. Give me a pair of corresponding angles. Angles that match up. Here we go, 20. Let's go, Radhika, and just give me a single letter here, Radhika. No need for 3 letters here.
Okay, angle W and angle B.
Got it. Angle W is congruent to angle B because they're corresponding parts in congruent figures. All right, let's keep going. You guys are doing a nice job to start out today. Here we go. Atticus, give me another pair.
Angle D is congruent to angle Y.
Got it. Okay, a third pair for me. Here we go. Going Caroline, back to you.
Angle A and angle Z.
Got it. Yep. Good job, guys. I'm going to ask for anybody for the fourth pair. Process elimination. It's going to be angle C and angle X. All right. Now let me let you in on a little secret here, kids. All right. As everyone was telling me the corresponding sides and angles, I never looked at the diagram, but I still knew you were correct. And not because I've memorized the notes either. All right. I did not need to look at the diagram. I did not need to rotate it, flip it in my head to see if you were correct. I used something else to see if you were correct. Ready? Here's my little secret. I used the congruent statement to see if you were correct or not. Here's how I did it. Somebody told me under angles that angle W was congruent to angle B. Look where W and B are in the congruent statement, everybody. Look where W and B end up. Second position in both. Do you see that? Go, same thing for the sides. Ready? Somebody told me that CB, look where they end up in, is congruent to XW. Look where that ends up. So you can also use the congruent statement and try to, instead of flipping it in your head or rotating it in your head. Okay, does everyone see the power of the congruent statement? It's written in a particular order. And that order is where all your corresponding angles and sides match up. Everyone see how that works? And you can test everything else out too. It works perfectly. They're always in the same spots. Good deal? All right, so before I move on to the proof we have to do, if I know two figures are congruent, all their corresponding parts are congruent. All good? All right, how do I get them congruent now? That's the key. How do I get them congruent now? Woo! Here we go. Decide whether these, and I know you guys have a theorem box, and we will fill in 2 theorems as we go along today. All right, decide whether these triangles are congruent or not. How do I get them congruent? Oh, they look congruent. Baloney! We don't say it looks like in here. All right, we need a little more geometry than that. How do I figure out if they're congruent? Go back to that theorems box for me on your first page. I think it's on the first page. Your theorems box. Here's how we determine if 2 polygons are congruent or not. If all, and you may want to underline that a couple times, if all corresponding parts are congruent, the polygons are congruent. Okay. What did we just write? All angles have to be equal. All corresponding sides need to be. Everything, guys. We got our work cut out. Roll up your sleeves here if you got any. All right. We need to find all corresponding parts are congruent. All right, here we go to the triangle. If you got, I don't know if I wrote this in here or not. If I didn't write in the givens, go ahead, write in your givens. And as you guys know, let's mark your diagram. Oh, how excited is everyone that we are back to doing proofs? Yes, welcome back. It's been so long. Actually, it's just been last week on your test. Who are we kidding? A, B, and D are right angles. Nice. Look at all these givens. Wow. AB congruent to ED. BC congruent to CD. AC congruent to CE. Wow. Got it. All right, here we go. If I'm going to prove these 2 triangles congruent, again, I need all the corresponding parts congruent. Well, I gave you guys the sides, didn't I? I already told you all the corresponding sides are congruent. You're welcome. You have to help me. You have to help me prove all the angles are congruent now. So let me turn it over to you guys. Do you see any corresponding angles you know are congruent based on something we have talked about in previous units? Look at the diagram real quick. Name me a pair of angles you are 100% positive are congruent to each other, and be ready to back yourself up. Here we go. 4. Gideon, do you see any angles that have to be congruent right now?
B and D.
Good job. B and D are congruent, everyone. Angle B, congruent to angle D. Please use what we've used in the past. How does Gideon know that B and D are equal to each other? Boom, 21. Here we go. Zach, how does he know that?
All right angles are congruent.
Great job, Zach. All right angles congruent. Just keep in mind, Audrey, yes?
Oh, like for the thing I was raising my hand about?
Yeah, what's your question?
I didn't have a question. I was just going to answer.
Oh, all right. Sorry. All right. I thought you had a question. I want to remind people, if you're going to tell me right angles are congruent, you need to tell me what angles are right angles, which I gave you. Sometimes I won't give you that, so remember that. If you're going to tell me right angles are congruent, where are the right angles, which was given here. All right, you got the right angles congruent. You should be able to tell me at least one more pair up here are congruent. All right, if you know your if you're down into your geometry knowledge here. Come on, top notch here. What other pair of angles has to be congruent? Whew. Atticus, back to you. Do you see another pair?
Angle BCA and angle ECD.
Good. I'm just going to mark them and then I'll write them and then I'll ask somebody why Atticus knew they were congruent. So angle BCA congruent to angle ECD. How did Atticus know those two? The one I just marked in pink were congruent. Come on. Hasn't been that long. What do you got, Audrey? Why are those two congruent?
They're vertical angles.
Yes, so we have a theorem that says vertical angles are congruent. Oh, look at all this coming back now. Perfect. So I need one more piece left, right? I got all sides congruent. I got all angles congruent. The only thing I need is A and E being the congruent. And this is where I'm going to slow it down a little bit. Why A and E are congruent. Now, some of you may just start popping off with alternate interior angles, which they are, but I need parallel lines, which I don't have. So throw that out the window. Okay, don't give me that alternate interior angles. I don't have parallel lines. Okay. All right, so this is going to be something new. These are triangles, aren't they, guys? Two triangles. How many degrees in every triangle? 180 degrees. And if two pairs of angles are already congruent, shouldn't the third pair be then? Right, quick, take a look at my little diagrams here. Don't draw these. Here you go, 70, 70. There's one pair of congruent angles. 30, 30. There's my second pair. Doesn't this last pair have to be equal to each other if they're going to both add to 180? Everyone agrees? That if I have two triangles, that the third pair have to be equal. And go back. This is our second and final theorem. So go back to your theorem box on the first page. And here's how we're going to get angle A congruent to angle E. In two triangles, if two pairs of angles are congruent, the third pair must be congruent. After you write it, reread it. Making sure we're staying on task here. Everyone see that? If two triangles, two pairs of angles are congruent, the third pair must be congruent. Make sense? Oh, but I already know where some of you are going right now because I know you too well. That is so much to write. And I have to memorize that and write it in my reasons column? Oh, you guys are so soft nowadays. So soft, you got to write all that. Okay, I'm going to actually give you the name of this theorem now. That is what the theorem says, but you're allowed to use the name of the theorem in the reasons column. And ready for this name? The third angles theorem. The third angles theorem. I love that name. That's the only reason why I'm allowing you to use the name and not the actual theorem in the reasons column. Okay, you're welcome, by the way. You're welcome. You can use third angles theorem. So going back to our proof, angle A is congruent to angle E, third angles theorem. Whew. All right, now we have everything congruent, don't we? Do we have all three pairs of sides? Yes, it was given. Do we have all three pairs of angles? Yes, steps 2 through 4. So now I can say the two triangles are congruent, which is the last hurdle you need to get over here. When you're about to write a congruent statement, you're going to say triangle so-and-so is congruent to triangle so-and-so. But remember the rule when you write a congruent statement. Remember our quadrilaterals? The corresponding sides and angles have to be in the same spots. So you can start out by calling the first triangle, triangle ABC, triangle CBA, however you want to name the first triangle. But when you go to write the second triangle, the angles and sides have to match up. Go ahead, try it out yourself. Try it out yourself. There is no one right way to write this, by the way. There are multiple versions of this congruent statement you're writing right now. So name the first triangle however you want. That doesn't matter. Second triangle, though, got to make sure angles and sides match up. All right, give me your version right now. Give me your congruent statement for me. Your congruent statement. Here we go. Sinjin, what do you have for your congruent statement?
Triangle ACB is congruent to angle ECD.
ECD. All right, I just write it down and then I check it at the end. A and E were congruent. Angle C and C. Yep. B and D, good. Let's see. AC was congruent to EC. Looks good to me. Yep. That's one good statement. One good statement, guys. Only one. There's multiple ways. You just got to make sure your sides and angles match up. And what's the reason for the triangles being congruent? Remember our theorem number 1, if all corresponding parts are congruent, the polygons are congruent. Okay? And I know some of you guys are like, we have to write that as well. You can write that, that's fine. Or I'll also accept the following, a little shorter version, which is definition of congruent polygons. So you can write theorem number 1 out, or definition of congruent polygons, whatever you prefer. Wow. Whew, I'm exhausted already, and we still got another proof to do. Anything you guys want to ask here? So if I need two triangles congruent, you need to show me every single corresponding part is congruent to each other. I know that's a lot of work, but it's only a lot of work for tonight. The rules change tomorrow. All right, let's go. One doesn't make you great. Let's buckle up, set it up, mark it up. You guys know the drill for this next one. Set it up, write everything in, mark it up. Whew. Guys all set up? Here's what, before we start talking about it, there was a given that had GN perpendicular to CD, GN perpendicular to CD. What did you guys put on your diagram for that? Just interested. Here we go. Caroline, what did you put on your diagram for the GN perpendicular to CD given?
The right angles.
Good. You should add right angles here and here, everyone, on your diagram. Okay, here we go. The proof statement says prove the triangles are congruent. So I need to show all angles and sides. So let's start with the angles because I did not give you any angles. I gave you one pair, C and D. Okay. Where do you want to start with angles? Do you know a pair of angles that are congruent here? Oh, there we go. Sean, do you know a pair of angles that are congruent?
Angle CNG and angle DNG.
Correct. Yep. CNG and DNG. Everyone agree? Hold on, though. This is what I warned you guys about last proof. They're not congruent yet. Somebody can open up their mic here. What do you still need to tell me before you write those angles are congruent?
The right angles.
You got to tell me the right angles. Good. So first thing is angle CNG and angle DNG are right angles. Got to tell me the right angles. Some of you guys may have written definition of perpendicular in the past. I always like writing perpendicular lines form right angles. Now, in the next step, right after that, go ahead, tell me they're congruent. Get in that habit. Tell me they're right angles, tell me they're congruent. We use this last proof, all right angles congruent. Everyone with me? No issues so far? All right, so you got the right angles. Can we just go, why does the other pair then, the remaining pair, CGN and DGN, have to be congruent? Don't start putting words in there that aren't there. Somebody may want to tell me definition of a bisector. There's no word there that says bisects. You have two angles already equal. Why do the remaining pair have to be equal? CGN congruent to DGN. That remaining pair, you let me know why they have to be congruent. Look in your notes. Look in your notes. That's all I can really tell you. Atticus, why do those last pair have to be equal?
Because of the definition of congruent. Wait, the third angles theorem?
Third angles theorem. Everyone see that? I already have two pair, so the third pair has to be equal by the third angles theorem. Okay, third angles theorem to get that last pair. All right, I'm almost done. The only thing I need is one more pair of sides. And I want you to look at that pair of sides I need to prove. And tell me if you notice anything odd about it. What's the last pair of sides that I need to prove congruent in both triangles? Ooh, here we go. Sophia, do you see the last pair I need to prove congruent?
Yep.
What is it?
It's just GN and
Right.
GN.
GN for the one triangle, and again, GN for the other one. Everyone go back to the very first postulate I showed you in Unit 2. What do you know about GN and GN? They're congruent. Anybody want to open it up right now and just tell me?
Reflexive?
Reflexive postulate. Boom! There it is. That's where it's going to be coming back. When you see a shared side or shared angle, reflexive. All right, you guys got everything you need. Look at that. So here we go. And you don't have to worry about the order of the sides or angles for this one. Don't worry about the order because it was in the proof statement. You just copy the proof statement. Triangle CNG congruent to triangle DNG. Good. Definition of congruent polygons. In two, if corresponding parts are congruent, the polygons are congruent, whatever one you want to use. There it is. Not too bad. And I believe you have two tonight. I know we're not done yet, but I believe you have two proofs tonight to try out, very similar to these. Prove the triangle's congruent. Questions from you guys? Okay.
By the two questions, I assume you mean the stuff that we were assigned in the textbook, not the two examples we have listed here?
No, you have, for homework, as part of the assignment out of the textbook tonight, I believe two of those problems are proofs. So that's what I was talking about. All right, here we go. Next up, you guys have something different there. Just want to change that. What do you guys have? You guys have R... SV, thank you. RSV, thank you. Okay, here we go. So let's find the values of X and Y. Hey, remember, they're giving me the triangles are congruent, which means all corresponding parts are equal now. Once I know they're congruent, all the corresponding parts. I just want to know, do you want to find X or Y first? There's no wrong answer. Will, do you want to find X or Y? It's your call. You're going to dictate where the class goes now. X or Y, Will?
Y.
You got it. Thanks. Find Y, everybody. And you'll notice Y is part of 2Y minus 1, which is on, and you don't have to write this, I'm just trying to show you guys. That's on RS, right? That's on RS. Can you guys find what RS corresponds with in the other triangle? If you can't do it visually, use the congruent statement. Look where R and S are in the congruent statement, the first two spots. What's in the first two spots in the next triangle? TV. So RS and TV correspond. TV is 24. So 2y minus 1 equals 24. And so it's okay. I will be the first one to admit I always have a tough time flipping and rotating figures visually. So I just cheat. No, I don't cheat. I just look at the congruent statement. So 2y equals 25. Oh boy, we get decimals in honors? We do? 12.5. And now we got to find x. Okay, x is a degree measure, right? Which is angle, it's angle t. Can you guys figure out what t would correspond with in the other triangle? If you can't flip it, use the congruent statement. T would match up with angle R, but I didn't put anything in for angle R, did I? So real quickly, how can you guys find angle R? Even though it's not written in. Maeve, finish this off. How can I find angle R?
You add 98 and 90 and then subtract it by 180.
There we go. So I got 180 minus 90 minus 78 will give me angle R, which I believe was at 12 degrees, you kids? 12?
Yes.
Thank you. 12 degrees. All right, everybody good? We'll do example 4 first thing tomorrow. Check your homework answers, please. Check them and then ask your questions tomorrow. 1 o'clock deadline, Google Classroom homework. Have a good day, everybody.
Thank you.
Thank you. Thank you. Have a good day.
Yeah.